Whoa. Hello. Oh. Ha! Yeah, the wrong window open. Come back. That's better. Ha ha! I can see you. You can see me. I can see you seeing me. Yes. Yes, I am cognitive. I don't know if I'm all here, but I'm cognitive. I hope we're all doing fine this evening. Let's see. We got a Humvee in chat. Hello. And we got a Green and Ash and a Spot Porsche. Oh my. Oh, mighty fine. All right. I'm playing what we call large game of red light, green light. Indeed, I have appeared, but so have you. All right, here's going to be the nectar of the way this evening is going to work out. I have to keep my eye on something. And if it requires me to steal my attention, I've got a long form BRB screen will go on. Hello, camera? Ah! I am broken. Why did my camera do that? Why? Yes, I'm in the middle of talking to the audience. Can I not pretzel, please? My word. All right, everybody, I'm gonna break my shoulders. Gotta love that. Yo, that's a good point, Green. You are hilariously late. Oh my word. So yes, if I need to pivot, I'm gonna just put y'all on the long form BRB screen, and then I'll return. Yeah, so that's what we gotta do. So here's the general direction of this evening. I'm gonna show you the update to the Protogen code. We're not there yet, but we made it over another big ass banister of a wall this time. I've gotten both boards communicating pretty close in the way I want them to. There's one thing I'm going to show you that we may or may not need to change, but for right now I'm going to leave it alone, because I still want to continue forward. I can always go back and make modifications to the way this is working, but for now I'm classifying it good enough. We're filing it under it works, and it works mostly well, but you'll see where there's some caveats here. So we're gonna do that first, and then with our remaining time we're gonna play some more of the game about the tentacle, Day of the Tentacle. So we're gonna do more of that too. We're gonna pick up our game save from there. So enough ranting and raving, let's get into it. So I can confirm to you that this hurt a lot. For any of you that were keeping an eye on my oh no, bloody ads, sorry about that, Porsche. For any of you that are in my server and have seen my running notes, the running notes is just kind of an area where I just dump my brain so that I don't get welcome back from the ads, pretty good. The notes section in my server is a running section where I basically just keep track of my madness that this is, so that I don't lose my mindset, because when you work on code and you get tired, you start losing the ability to think logically, which is what you need to write code. So in an effort to not lose myself, there's just a lot of noise in there, but we made progress, because I got these working. A little bit of a recap, now that we're back from the ads. The last time I showed you the code, when it was working, I had the first board talking to the second board in a mode called broadcast mode, which means anybody it's within earshot can hear this message. Boom, out goes the broadcast. You know, I like grilled cheese. Okay, that's broadcasted to the audience, right? And all of you heard me say I like grilled cheese, because frankly I do like grilled cheese. And anybody who's within earshot will hear I like grilled cheese, right? So both boards being in a broadcast like mode means you'll hear each other. When you are in a room by yourself, like what I've got here, you all are going to clearly hear me say, I like cheese, right? Because there's no other noise or interference preventing you from hearing that. Now, in the context of a convention, there's thousands of people wandering around, right? And if I've got two boards that are just talking back and forth in that same exact mode, I'm glad you like cheese. That's the right answer. Cheese. If I have two boards talking in a mode saying, to whoever can hear me, accept this message, then what can end up happening is interference. Say that there's more than one of this particular project in the same room behaving in a similar fashion. Or hell, not even exactly this same project setup, but just another board. ESP32s are everywhere. That's also operating in broadcast mode. And if they're on the same channel, that means they're essentially in the same room as each other. So if I said to anybody and anybody, I like cheese, and then there's another board in another chunk of the room on the same channel, because when you're on the same channel, you can hear each other, say the broccoli is steamed, then the receiving...
Bob, can I get a glass of water?
Fine. I'll drink my water. Actually, it's hot tea. It's delicious. It's hot English tea. Highly recommend. The receiver's going to hear both messages. So they're going to hear I like cheese, because who doesn't like cheese? I mean, even if you're lactose intolerant, you still like cheese. I don't know anybody who's lactose intolerant that doesn't like cheese. Okay? It's a different commitment, but no here nor there. But when you're both on the same channel and you're both talking in broadcast mode, anybody can hear anybody. All right, that's the point I'm trying to make. And I knew that would be a problem, especially if multiple people use this code. It's going to get published when I'm done with it. I knew that would be a problem. So I needed it to work so that each board would send out the message in a Unicast format saying, hey, you over there in the corner, this is for you. Now, it's a little confusing because a Unicast still goes out to everybody, right? It's still sent in a way. Did someone say cheese? Sasha, you are in the right place. Because a Unicast is still sent in a broadcast-like fashion, but it's crafted in a way that it's directed towards someone. So instead of me just saying to the room, I like cheese, I point to Sasha and say, Sasha, I like cheese. And then Sasha could either deny or confirm that madness. Howdy, Robert. I am working on building a Protogen Head. This code is in relationship to building one of these that you see me in the lower corner. I am not into the physical aspect of anything beyond just this initial hardware. We're working on getting controller data from the first ESP32 board to the main board that will be plugged into the screens that will allow us to change the expressions and faces on the built head. So that's what we're working on. Now, when a Unicast is sent, it's sent to the room on the channel. So say you're on channel 1 and you say in a Unicast fashion, to the room, Sasha, I like cheese. That message is directed at you. Everybody else has the ability to hear it because you could put your board in what's called promiscuous mode and capture everything, whether it's for you or not. But boards that are configured to just operate in a normal fashion or traditional communication fashion will ignore Unicast traffic that's not for them. They can still see it, but they ignore it because it's not for them. I knew that's the way I needed this to work. And then I also turned on encryption because if for some reason that two boards add each other as peers and they're not supposed to speak with each other, then the data will come across, but it'll be encrypted. And unless you have the decryption keys for the other end of the communication, you're just going to get noise. You're not going to be able to do anything with that information that comes across. We're not working with anything here that's mission critical. I'm sorry, Sasha. By all means, if anybody wants me to expand further on something that I'm talking about here, I'm more than happy to do so. I'm gonna do a little scrolling and actually point out the different things that are happening here. I'm not just gonna, say words, but there's a reason I brought up both screens at once, because I can tell you right now, this was a living hell in an operation to try to figure out. Whoa. Hold on, back up the school bus, put the flashes on. I see you, and you see me. Hello. Indeed, you've caught me. Indeed. Well, see, this is this cool thing, right? There's this cool thing I can do, right? If I can spell, right? I can do that. She is a lovely bean. Follow her. It's good to see you. What scene was I on here? I was on this one. I mean, that's fair, Sasha. But by all means, maybe the show and tell portion will make a little bit more sense. But just the concept of either you're talking to everybody or you're just directing your conversation towards one person. Because in a room full of people where everybody's talking, if you're standing in front of the other person who you're speaking with, and you send out your message, sure, other people can hear you. There's background noise, but directed towards one individual and, more or less locking up the conversation for those who can't hear it, because that's how, cryptography works, puts us in this position where if multiple of these end up in the same room, they likely shouldn't butt heads with each other once they're in that one-to-one communication. And I'll show you what that's all about here. BF was coder. I don't know who BF is, or if that's an abbreviation for something. So, okay, all right. I have ranted enough about what the theory is here, because I've expressed that several times over the course of trying to figure this out, and now I finally got it, and I'm excited. I am not. Okay, Roger. Oh, yeah, boyfriend. That makes sense. Thank you. Hi, Dredrick. Welcome on in. I should have been able to understand that. See, I struggle so much with abbreviations because they can mean different things depending on the context. Like an ISP to me is usually an internet service provider, but that's not the same thing in different contexts. So by all means, I might ask stupid questions like that one. Okay, all right. I'm not going to go through everything. I just want to cover the main. Yeah. Oh, absolutely. We're doing burnouts in the parking lot of my mind. I'm not even mad. I'm just going to cover the key points. I'm going to shoot some sensor data back and forth, and then we're going to jump into a game. Because to be honest, there's a lot of code across both of these projects, and I don't want to kill either of us. So, all right, we're going to start with the controller side. The controller side is this window on our left. You're going to notice that some of the stuff is in both sketches, between this one and the one over here, which is the screen. Right now, the sketch that's for the screen does nothing with screens, right? This is simply just taking data, accepting it from the other board, and just storing it. I think it actually dumps it to the screen, if I remember correctly. Actually, now that I say that out loud. Yeah. So it just accepts it, dumps it to the screen, and does nothing else. So you're going to see nothing in here in relationship to screens yet. That's coming soon. So first things first, I added an additional element that wasn't here last time to the Wii controller index variable. So what this is this is just essentially a list of the different elements we're going to have in our array of byte data. So think of a byte as a container, and it can hold between 0 and 255. That number fits in the space of 1 byte. There are different types of storage for different elements in programming. So integers, there's doubles, there's longs, there's strings. These are all different containers, Tupperware containers, that we hold stuff in, right? This one in particular has a total of 8 elements. So this is 8 bytes worth of stuff that we're going to name. I added this new one called device type because in the future, I still like the idea of adding RFID technology to this project, but I have made a realization that if it happens, it's going to have to happen later. I was getting pretty hung up on that, and I decided if I just build this in the mindset that there's going to be more to come later, then I won't have that much to change to make it work the way I want it to work. Because the reality is I could always modify the code, and assuming that the hardware internally inside the head will stay the same, then I could take as much time as I want to incorporate as many other things into this. And the additional hardware I want to add isn't going to be in the head. So I figured, let's get the head hardware figured out, and then we could start working on 3D printing. We could talk about bases, and then hell, we could talk enclosures and eventually sewing and furring. So like it's this whole like keep the project moving along, because make it exist first and then you can make it better later. That doesn't mean do shoddy work up front. That just simply means that continue moving is really what I'm trying to get across here. So the reason I added this device type is so that in the data that's going to whiz back and forth, hi Pine, welcome on in. I wanted to include in the data essentially an identifier so that I know who the data came from. So for the controller, this will always be the same number for the controller type. Unless I involve a different controller. But for the specific controller that I'm using, this variable is going to stay the same regardless. And then all of these are the different values that the controller will store and then shoot across the wire. Well, I guess across the airways, there's no wire. To which then from here, we actually declare our byte array. So this is the actual container, and then the number of elements was this cool little trick I found that gets us the number of these and then slaps them in here so that we can actually name the variables that are going to be stored inside of here. If I didn't do it this way and I didn't declare these with a name, then this would still work if I just typed an 8 in here. But then instead of storing inside of this variable the data with a name, this is why I said we're not going to cover all of this. But I do. This is relevant, so I got to go all the way down here. When I go to store it later, then I wouldn't have the nice name because I'm going to get the sensor data, but I'm storing it into a variable with that name. Now they're all held together inside of this one array of bytes, and it's called we controller data. So inside of that is 8 different variables, all with slightly different names, and that's the inner name. So the only reason we do it that way is so that we can make sense to us. The people are Protogens, so they're going to have to read it later. It makes the code more consumable when you're looking at it later, because I could look at this and know, oh, well, this is the variable that holds the true or false statement if I'm clicking that button. But if it just said controller data 0, 1, 2, 3, 4, there's no meaning there. And by doing it that way, it adds the meaning, right? So that's the whole theory on that, right? So then now we're digging into ESP-NOW, okay? This is the protocol that really promptly kicked my butt for a good long while. Some of this stuff is going to be similar, and there's a couple of new things in here. we're going to put ourselves in station mode. We're going to set our Wi-Fi channel. In the United States of America, you've got channels 1 through 11. Depending on your country, these will be different. The full spectrum for Wi-Fi is between 1 to 14, but again, those extra channels are country dependent. You cannot use those extended channels in America because that's not a part of the Wi-Fi spectrum for Wi-Fi. It's used for different things in America, and by following along with the rules of the rest of the world, that prevents interference. So you play by the rules with this stuff. You don't screw with the FCC. That's bad. Don't do that. You'll live longer. So we set that, and then here we set our interval of how often we would like to send our messages. This can be adjusted based on the application. This is something new, the peer count. So every time I've shown you one of these sketches, it starts, and then it just loops, and it just loops, and it just loops, and it just loops forever until it loses power or I restart it. This is going to wait until we have one neighbor saved in memory before we start our loop. Once we have that neighbor locked in memory, then we start our cycle, and we'll just keep cycling and cycling and cycling. I haven't made up my mind if I want to leave it this way yet. And you'll see why. We'll get there. But for now, I'm going to leave it because A, it works, and B, it's not a bad thing. I just don't know how functional it'll be out in the wild. So for now, we leave it alone. And then this could be ignored. I forgot to delete that. We are going to come across some code that I may not have gutted. So I'm just going to skip over it. That one I know we can ignore. And then I have my super secure pre-shared in local keys that I'm showing the internet that I haven't changed yet. I left these are the default that came with the example I was working on. This you very much change and don't tell the rest of the internet. So I just left them alone for now. The primary master key and the local master key, you are required to set both. The primary master key is the one that you share across all the boards that need to be able to speak with each other. The local master key is the key that you use to speak across one-to-one or any other peers that need to talk with each other. So if I have 5 boards and I need the first 2 to be able to talk with each other and the last 2 to be able to talk with each other, then for those boards to be able to talk amongst themselves, then the primary has to be the same regardless. And the local key, if I need those 4 boards to speak with each other, will have to be the same. For the one that's in the middle that I ignored, if that one's not supposed to speak to the other neighbors, well then you could just change the local master key on that, and then they won't be able to chat. Even if they have each other added, you can absolutely add a board that you don't have the ability to talk to. I know this because that's how I confirmed that these keys were actually working. I modified the local master key, made it something different, and then neither board connected to each other because it couldn't find the neighboring peer. A board that's in a mode where it's just waiting for anybody to say something may be able to add it, but again, it's encrypted. I won't be able to understand it. So it's important that if you're gonna set a local master, that you have to choose something for the primary master. And then you'll notice that these are both exactly 16 digits long. Both keys must be 16 digits long exactly, whether that's a combination of 16 numbers and letters, or just numbers, or just letters. It matters because it has to be actually technically 16 bytes, and each one of these numbers or letters is a byte. Simple rule, and that's just a part of the way that the cryptography needs this to be formatted. So that's why they're both exactly the same length. And if I accidentally chopped one of these off and saved it, or made it longer, it won't work. They won't be able to communicate. So this is one of those times that having some handy dandy documentation certainly comes in handy. So I learned that little tidbit from, I think I found that from the manufacturer's document sheet or data sheet, if I remember correctly, because all of the stuff that makes these things work is up on the manufacturer's website, even though this board was produced by Adafruit. The actual spec that makes the little processor function is published by them. And then from here we have some stuff. There are attributes to the data that we're going to send across the wire. Now, I'm going to be real with you. I don't fully remember exactly what those do, because again, I didn't cut all of the code that wasn't supposed to be here. Because we have some counts that are going to be in here that we don't use. Like we don't use that one. We don't use that one. We do use this. We do use that. We do use that. I don't remember if we use the self priority. I know we're actively not using this one, so we can ignore that. You have to be careful because when you start gutting stuff that you don't use, you need to make sure that there's other code that's not calling on the thing you deleted. Because like I know I commented this out and then it broke because it's technically referred to further down in the code, and I figured, you know what, it's not hurting anything, I'm just not using it. It does use space in the program, and I'm gonna need as much space as I can on the other sketch, on the one that's over here, but in time I can refine it and just remove the junk I'm not using. So here's the long and short of it. We're going to build a class that is going to call upon the different functions that are built into the library. That is a bunch of words. Let me try to break that down. Inside of the library is a book, and inside the book is a list of all the different things you can use the board for. For me to specifically use something from within the book, I need to create yet again another container and give it a friendly name I could use in my code that just points to the thing in the book that I'm going to use. That's essentially what a class definition is. It's a friendly name that points to something that's hard coded in the library book. We can't change the library book. That's just where it is. But what we can do is point to the thing and say, what I need is over there. So understanding how this worked, it made me sad that I couldn't identify that and like express that in words that made any kind of sense even to me, let alone anybody who may be watching. But that was a tough hurdle to get over. And the thing I struggled with was creating a peer, because I was screwing around with this up here, which is our friendly name that we can call upon lower in the code and then shove stuff into it. And then the code does the code thing. What we do up here is we store our peer, and then these are all the things we need to provide to the code to make that happen. So we need to know the MAC address of our peer. We need to know what channel it's on, what mode it's in. In this case, it's always going to be in station mode for this example. And then it's a local key. And then the priority is that changing integer. Everybody needs a priority, and then we need to know who the master is for doing any kind of point-to-point communication, because somebody needs to know who's in charge by the way that this code works. That's what I struggled with when I tried to turn the broadcast project into a Unicast one, is that Unicast doesn't have priority, it doesn't have a master, and it also does not accept the encryption key. You want to know why? If I broadcasted a message to the whole room and encrypted it, none of you are going to be able to understand me. If I said I like cheese, but I stuffed that wording behind some gobbledygook, and then Zeblar Blop came out on the other end, well, none of you understood the phrase, I like cheese. Because you can't broadcast an encrypted message without the other end knowing of your existence and having the decryption key. And that's essentially what I was trying to do for like 2 days before I found out I was using the wrong example. And promptly, shredded brain cells trying to figure that out. But we got here. So that happens. And then we have some destructors here, destructors. Technically that is a destructor. But we have some constructors here on essentially what we need to complete certain actions. In this case, this is sending a message. We need the actual data and then how long the data is so that the other end can know, hey, I'm about to send you a message. It's 5 bytes long or 8 bytes long. In this case, ours is 8 in length. But the numbers inside of that package are going to morph and change as we send the information out. But the other end needs to know that, because if it changes, then we need to inform the other end that a different length of information is heading your way. Otherwise, the board won't understand how to handle it. It'll crash. All right, so then we have what to do when we receive it. And then that takes care of the class definition. I'm just going to skip over that other section. That's the same as what we've covered before. This is where things get a little convoluted. Because what we need that's further down in this madness that we call the coding project, but you'll notice something here. This if statement will only run the code that is between here and here if the message to come in is not a broadcast message. If it is a broadcast message, right, not true, so that means a Unicast, then it runs the code. Otherwise, it ignores this block. What we do from here then is that we dump out who the peer is to the screen, and then we store with these data pushes who the other end of the conversation is. Because essentially what this is going to do is it's going to send out a message saying the string hello. Hello? Is somebody there? It's going to do that. And then once the other peer goes, yeah, I see your homie, they're going to add each other. They're going to be yo, you're pretty fly. And then they're going to write down each other's addresses, because that's not creepy. But that's essentially what's going to happen. And then from here, we're going to send data. So that happens. And then this is a function for sending data. So I'm going to jump over that. If bad stuff occurs, we reboot. That's if we fail to start the protocol that's going to send data back and forth, and then wait for 5 full seconds, and then try again. Let's see here. This is where we check to see who has the highest priority. In the example, we use the MAC address and some ugly looking math to generate a number that's going to be unique, and then whoever has the higher number wins, and that becomes the master. In this specific example, I wanted the screen to always be the master, so I needed it to always win that calculation, which made me think, well, maybe I should hard code that number, which then I did, but I only did it on the screen side. I'll show you how I came up with the number that I did. So we make sure everybody's ready, and then once we're true, we rock and roll here. Let's see here. So this is the section on adding a new peer. Without going too in depth here, these void statements are a little block of code that I can call upon multiple times in a row. In this case, void means it returns nothing. So it executes a bunch of stuff, but doesn't return anything back to the main application. So this is how to register another board. And I can call on that as many times as I need to at any point. And then the code stops what it's doing, runs this block of code, which, where does that end? Where's that curly brace begin? I think that's down here. Oh, that's that statement. All right, you start there and then run all the way down to here. So this block of code is the whole function of adding somebody new to the mix. We're only ever going to wait for one right now to be added because that's going to be our other side of the fence. And then that's the same thing. We determine priority, and then peers.pushback takes all the information about the peer that we just saw and then store it into a variable, and then it's that's it. That's all that does. Now that we've gone through all the setup, or the initial code, this is the setup section. So this is the code that runs right before we jump into the loop. So everything above that is just the precursor to getting us where we are headed. We have a variable to store our own hardware address. Think of the hardware address in your head as the number that's associated with the plot of land you live on, and your mailbox address being your IP address, right? In theory, your mailbox address that points to you could change. It's actually happened in a couple of cities where they pick up a house and they move it. But the plot of land that your house is sitting on never changes. So think of the address, the MAC address, the hardware address, is one that A, can't be changed, and B, does not change. This is something that I had to add because the startup, I think I was talking to you guys before about this, that we weren't seeing these execute when I would run the example down here in the terminal. And I figured it was just that it was running them before it was connected to the serial monitor, which is the little box down here. This wait command will wait indefinitely until there's a connection between the code and the box down here, which means that when I unplug this from the computer, the project won't work when I power it on because it's waiting for a connection to the computer, which means this is only temporary while we're just tinkering. It comes out when it goes into production. We then put ourselves in the appropriate mode. We dump some basic information to the screen so we could see what's actually happening. We then take our MAC address and then determine our self priority based on math. This is a mathematical computation. And then it dumps our priority number to the screen. Once we were rocking and rolling that, we start our connection to ESP-NOW. And then we reboot if bad things happen. We saw this earlier or further up in the code. This is one of those pieces of code I'm calling upon that's written further up in the project, because if we need to call it again, well, instead of having 5 or 6 lines repeated a second time, you just call it once. You can call it as many times as you want. More importantly, if you have to make a change to it, you only change that code in one place, and then all these calls are updated automatically because it just says, hey, I need you, and it goes, oh, here you go, instead of having to change it again and again and again. That's a really easy way to keep your code organized, so that A, you don't get lost in your own stuff, like I tried to not do, and it keeps it clean and neat. We then will call upon our registering our new peer by passing the information of the parameters that we've configured up at the top. So it's asking for the information about the peer, and then some length arguments. We then have a null pointer, which is just pointing to nothing. For some reason, it's required for the class. to use the class object from the library to have a pointer, and if you don't have a need to set it to anything, you have to set it anyway, or the code won't work. It won't even compile. You'll just see a bunch of red errors. So that's an important little tidbit that is not optional. Okay, so then we say that we are ready, and then we're waiting on the master. So we've figured out our own priority, and then what happens here is that, remember how I said that we just say hello? There it is. We say, hey, how are you? And then we attach our priority to that message saying, hi, how are you? I'm number blah. You know, it's a bit of a long number. And then the code stops, because we specifically said we're waiting on at least one peer before continuing. So everything that happens from that area up top down to here will not execute until one neighbor is found, which means that board is going to sit in broadcast mode saying, hey, how are you? Like SpongeBob. It's just going to keep doing that until somebody says hello back. Now, when it adds the peer, if it's the correct peer that has the same encryption code and decryption code, those local and shared keys, then communication will occur. If it's not, well, then you've added a peer that can't speak back to you and no traffic will pass. The data will be sent out, but the other end won't understand it. That's why, by the way this works right now, as long as both boards are in the same room and they're starting up and nobody else is also starting up at the same time, this won't cause an issue. But if you have more than one Protogen in the same room that boots up in the same configuration, this could cause trouble. So I'm not sure if I'm going to change how this works. Right now it works, and once the connection's established, then it's perfectly fine until both boards are turned off again. From off, then the boards are back into that. We need to find our partner again. And then once we found our partner, we're good to keep communicating until the batteries die. It took a lot of effort to get me here. And I'm not scared of getting it so that I could just manually declare who the partner is and not go through the broadcast route. But I'm gonna be real with you, I still don't understand how loading the objects work. I kind of have a bit of an understanding, but I don't understand it well enough to change the code to do that. But my ideal circumstance would be to hard code it so that each peer just points to each other, and then you're just chatting away. Like picking up your cell phone and going boop, 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 boop. And then you call and you're like, yo, bro, I want a pizza. I want cheese on my pizza. And then the pizza guy on the other side's like, yes, man, I'll get you that cheese pizza. And then it happens because it's a one-to-one communication. But we'll see. I don't know why I'm hung up on cheese this evening. See, I have troubles. I got it in my head. And apparently it's there to stay. So we wait for our friend. And then once we find our friend, we then fall into this block of code that determines who the master is. So if you are not the master, you then just broadcast a message saying, hey, I'm over here. And then we wander through figuring out who's the priority. Once the priority is determined and we know who's the higher number, we either become the master or we don't. We spit that to the screen, and then assuming that the device is not the master, I told you this board is not allowed to be the master by the way I wrote it. So I know for a fact, mathematically, it can't become the master, which means that do the sensor data thing. So then you're going to talk to the controller, you're going to get the values of it, store it in our variable, dump it to the screen so we could see it because we're still building this. And then a quick note, you'll notice that the statements for dumping to the screen the buttons to be C or Z, the buttons are either true or false because they're Boolean. Boolean is true or false. They're not a byte in nature. it's a Boolean statement. We're storing it in a byte, which means there's a little extra space, but you can still fit the size of a Boolean inside of a byte. There's just a lot of room in the container because it's smaller, because it's either a 1 or a 0. It won't be anything else. A byte can hold anywhere between 0 to 255. Howdy, Pixel. Welcome on in. It's a Proot trying to build a Proot. That's what's happening right now. And then we call upon our sending message, assuming that we're not the master. Which again, our assumption is that we aren't the master. That's the important part. And then we delay a total of 5-ish seconds, I think is what I hard-coded. I'm doing well. We are in the midst of working on building a Protogen. Right now, we're just diving into the code of getting my controller to control the faces over to the screen data, to the screen board, so that we can read the data, and then change expressions and be able to configure some other silly things that I've got planned. Assuming they can pan out and I can fit it into the project, like fans, for example. Well, I can tell you something, Pixel. When I am done building this one, this code is going to become public. I have to figure out where I'm going to stuff it, but I can confirm that if you want to build one based off of what I'm doing, I'm using a public base for the actual 3D printed parts that somebody else made, and I'm just making the code and borrowing from another Protogen that has a code repository that is free to use for personal or commercial use. The only thing that they are is limited liability, which means that you can't, they're legally outside of the realm of anything that potentially bad that could happen. Well, if you don't have a 3D printer, there are also services online that could print 3D things for you. So if you don't own a 3D printer, there are options for that. You just need the files, and the files are publicly available up on Thingiverse that you can use to submit to a company to have them printed on your behalf, and then you get to put it together. I'm gonna be real, I don't know how much soldering is going to be involved in this. For right now, it's mostly plug and play, but we'll see exactly how involved this is going to get. But I can assure you that if you want to make one like mine, the resources will be out there when I have it figured out. Right now, we're still working on that part, because I have no reason to gatekeep it, and I'm reusing stuff that's freely available to anyone, which means in turn, I'm also going to do the same. So long and short of it, this is how we get the controller data out of here and over to the other side. We're going to show and tell the other side, and then I'll plug the boards in, and then you'll be able to see in real time the action happen here. Well, I can assure you of something, Pixel 6, that the first step into doing something that's new is to just jump into it, which sometimes you're jumping into the kiddie pool and you don't know it. Other times it's the Marianas Trench and it just keeps going and going and going. But to be honest, if you want to learn something, you got to jump into it. And there's a lot of scariness in that sense. I was stuck on getting these two boards to communicate for like 2 days straight, and I spent the better half of about 8+ hours trying to figure out where I was gone wrong. I had probably about approximately less than 100 tabs open on my computer and using about probably between 30 to 40 gigs worth of RAM because of all the crap I had open, wondering and shaking my fist at the world going, why doesn't it work? And then I got there. And I can assure you, getting stuck doesn't mean the end of the world, but it does sometimes mean it's time to stop what we're doing and give it a hot minute. It's not losing $1,000 if you learn something along the way, but I can assure you, I can agree, it's certainly an expensive mistake if it goes poorly. But hey, sometimes mistakes are a part of learning, and that, my friend, is the long and short of it. Sometimes it hurts. And I can tell you, when you spend a lot of hours getting nowhere, my God, does it hurt. but my God, it feels so good when you secure that thing you couldn't figure out. I can't express to you how excited and tired I was because I figured this out at like 1:30 in the morning, my time. I was very tired. I went, I've succeeded. I'm going to go face plant into my bed. And that was the end of it. And then I kind of celebrated a little bit more the next day when I was, conscious. I can assure you there's a lot of work that's been going behind the scenes, especially when I get lost. But no here nor there. What do we got? All right, we're cooking. We're cooking. So I'm not gonna go over the same exact stuff again. I'm just gonna go over the differences. So you're gonna see that I built this to be exactly the same name in same structure. I could have given this a different name and it still would have worked, but I figured no reason to make it something different. It's easier to understand that if I'm sending this on this side and I'm accepting it on this side, don't change the names, because then the understanding is still there. The compiler doesn't care what this stuff is called. It's also that you can also understand your own damn madness, to which I am attempting to accomplish with minimal to maximal levels of success. I'm somewhere between. It depends on the day. All right, so we have to be on the same channel or we won't be able to find our other friend. We're also going to wait for at least one more board to appear before we continue to the main loop. This is exactly the same. Now, I do have a note here that says that excluding this device, so it doesn't say 2 because we're waiting for one friend, not including ourselves. That's an important context, because if you only had one friend you were waiting on, but you set the code to 2, that you're now waiting for 2 friends and you only have 1, well, then the other one's never going to appear and the code's never going to start. And then you'll be sad, because now you and your other friend are waiting indefinitely for no one. And that's sad. Nobody wants to look at a sad toaster, okay? No one wants this, okay? And we don't want to do this to ourselves either, which is why it's exactly the same. I've been reminded that I have a gig on Saturday. I really need to practice. Ooh, what do you play? What are we talking like? What do we got here? Oh, return. Fair enough. Well, hopefully you play something fun. Whether that be the guitar, the bass, the trumpet, the clarinet, I don't care. I'm sure there's gigs for, triangle players too. Everybody's got to be doing something. Then again, who knows? You know what? It just for me to take a stab at it, I'm gonna say that you play the drums. I'm probably wrong, but that's where I'm going. That's why final answer. I'm locked in. Please tell me I'm not wrong. Jazzy toaster. Oh, wait. So if you're a jazzy toaster, you play crap. I know what this thing is. Oh no, it's the you hold it like this. Damn it. I know what it is. I know what that damn thing's called. It's a saxophone. Okay, good, fantastic. Somebody says X. Yeah, I already hit the button and I was wrong. That's okay. I am the weakest link. Goodbye, apparently. Oh well, I've been voted off the island. I tried. Okay, again, I didn't cut this out. We could ignore it. These are the same or it won't work. This is exactly the same. This is actually exactly the same. All that stuff up there. Let's see. Now, okay, so what's a little different in this guy is the on receive. Now, if I scoot this back up to the on receive, you'll see there's nothing in here. Because right now, this board, that's the controller, that's just sending data. I don't have anything that's going to receive. It's just sending stuff. So I do have it declared in here in the class, which, as we mentioned, points back to the library that allows us to do stuff and things. I gotta find it. Please hold. On send. Oh, maybe I cut it out because I didn't need it. I might have got that out of here. On receive. I could just search for it. Stop being stupid. There it is. Yeah, see, it helps to use the things that are built into the program. okay, well, you have fun and enjoy and, you know, play a happy tune. You'll see here that this one contains a statement to just print the MAC address of who's talking, and nothing else, because I didn't have plans for this board to do anything. If I needed to do something, to accept something on this board, well, then I'll add something in here. But as far as it goes right now, I'm not doing anything like that. So that's why there's nothing over here. On receive is the function of what we do when data is sent to us. Now on the screen side, this is going to be the side that's going to accept the stuff from the first board. Now, as I had mentioned a little while ago, that when the compiler receives data, then it just comes in an array, right? It comes in one big Tupperware container and a bunch of smaller Tupperware containers inside of it for all the different elements. So big tub and inside a bunch of little tubs, and inside the little tubs is the data, right? Our actual sensor data. So what I did here is we have a total of 8 elements, 0 through 7, and I stuck them back into the same names. Now it's incredibly important that these are set in the same order I sent it in. That's why this is exactly the same layout that we saw on the other side. Because if I set data 4 equal to acceleration x-axis and switched it with joy x, it's going to be in the wrong variable. And then lower in the code when I go to manipulate it, I have the wrong sensor data in the wrong variable. No good. It won't make any sense. So we take it, we set it into the variables as long as it's not a broadcast. That means that when the peer, the board, says, "Hi, how are you?" in that fun little tone, it receives that message, but it doesn't store the hello inside of the device type for 2 reasons. One, we told it not to do that, but more importantly, hello is a string. This is a byte value. That would go poorly. It wouldn't cause the code to crash, but likely what it would cause is for garbage to get stored into this variable, and we don't want to do that, because like an old professor told me that I love dearly, garbage in, garbage out. That is the most important thing in any kind of system, whether that be a computer system, whether that be a you're talking to somebody system, like a sneaker net is what I'm thinking of. Sneaker net is like when you walk to the next person and then you tell them something, and then they go to the person after them and talk to them, right? We also call that the game of telephone. But when a system passes information around, if garbage gets into the system, it just makes a mess for everybody else further down the line. Which is why we're careful with when we store this. Now, something that I know that I skipped over, I must have scrolled past it down here, that I forgot to mention. I mentioned briefly, yeah, I did whiz past it. I mentioned briefly that the device type I had to set so that I would know on the other end who's talking. Otherwise, it's just sensor data, and I don't know who it came from other than the MAC address. And in an effort to keep this code a little easier to understand, I decided to just take the word numchuck, which I realize is misspelled here, that's numcheck, and just add the letters of the alphabet together, because that's less than 255, which fits into a byte, which gave me the number 32. So 32 is the numerical spelling of numchuck when you add all the letters together. I couldn't just put the word numchuck in here because this is a byte and numchuck is a string, because those are letters. You can't mix data types in an array of variables. It doesn't work that way. So on the other end, device type will always be set to 32. It's hard set here, and there's no calculation for it on this particular controller board. Later, when I'm hopefully at a bit of a better understanding of what's going on, and I want to add an additional board to send more sensor data from a different microcontroller, I will change this number. And then on the other end, what has to happen then is it will no longer be the data from this controller, but it'll be whatever data that came across, which makes this a little difficult to understand when we add additional things to it, which means that I may at some point change the names of these, or potentially do some calculation based on if this, you know, device type is set to a particular number to then maybe call on a different set of things to do. But for now, to keep it simple, this is the way we're doing it. There's one more thing I need to mention about this on-receive function. The manufacturer straight up says inside of the documentation, do almost nothing in here. All you want to do in the function of receiving the data is to just simply store it somewhere. Store it into a variable, store it directly into EEPROM, which is the memory that it will hold when the device shuts off. But don't do any calculations in here. Don't run any logic in here. Because on receive is given the top priority of the microcontroller. Other things are happening at the same time, and this on receive gets the priority above everybody else. If you start stuffing other things inside of this void function for on receive, you're going to cause the board to behave in very strange ways. I didn't realize that when I was first working on developing this part of the code, but I noticed that my microcontroller for the screen kept connecting and disconnecting from the laptop. I kept seeing this not connected message rapidly appear and disappear. And I was like, oh, that can't be good. Turns out that's why, because I was trying to do more inside of the on receive than what was reasonable. That's the word I'm going to say it. I didn't follow the recommendations of the manufacturer, and I felt it. Thankfully, I understood that once I bumped into that. And then after that, we just wander through the same stuff until we get to the part where we start to talk about the priority of this particular board. That's different. I need to find that. Because the function that sets our priority, I think it might be a little further down here. I did modify. Let me find it. Found it. All right, so we have the Wi-Fi MAC address and a self priority that is not 0. In the other board, it's set to 0, and then it does some math based on the hardware address to determine its priority. I wanted this one to win every time. So a byte can only store, or no, it wasn't a byte. What was this? There's self priority. I have to see how this was declared. Just a moment. Okay. I want to say this was a double. Actually, here, let me look. It's declared further up in the code. I just have to find it. There we go. It's an unsigned integer. An unsigned 32 int. Which can hold a pretty big number. And I figured if the priority has to always be bigger than everybody else, I'm just going to set it to the biggest number it can hold, which is this number. Funny enough. It's funny how it's not a round number. It's not. But That's how I came to the self priority. It's always going to win, and it will always be the master because I went with the biggest number that's capable of fitting inside of that variable. I literally opened up the Tupperware container and just dumped in all the Jello until it was overflowing and put the cap back on. And that's how we ended up where we're at. After that occurred, everything else is the same. The hello is the same. And then the code behaves a little differently because this one is the master, right? So this says up here, if not master decides. So if we don't know who the master is, then we're going to figure out who the master is. And then this is code that only runs if you are the master. And we are the master because we're always the master because I told it. It's not allowed to not be the master. And then all we do is we just take the information that we had stored previously on the onReceive and then dump it to the screen. This is just solely a running example so that you can see that this worked. And then we delay for a full 5 seconds or maybe 50 milliseconds. Shoot, I don't remember. That was declared somewhere near the top on both of them. It's exactly the same. 50 milliseconds. So half a second between transmissions. And that's it. So I'm going to plug these in one at a time, and you're going to see some startup data whiz by, and then they're going to stop. Once I plug in the screen, then both are going to start executing, and then sensor data is going to start whizzing back and forth between the two. This is proof of concept that the sensor data is leaving the controller and heading over to the screen microcontroller. Once it's in the microcontroller for the screen, well, now we have all the variables, or excuse me, all the values that we need to then decide what we want to do based on that. Because what we're going to do is we're going to set it so that we can change faces based on where we have the thumbstick. We haven't built any of that logic yet, but that's what we're going to do with it. And then we have some other things I'm going to plan for because I have a plan for the Z button on the controller. And there's a couple other things I want to build in if there's space on the project. Because right now I have done nothing with screens yet. And we're at, I believe, 40% program capacity. Which means we still got lots of space left, but I want to be careful that I don't run us out of space before we add all the cool stuff people are actually going to get to see. This is heavily involved, and this is stuff nobody's ever going to see externally. This is only stuff we see as the programmer. This is all the stuff that happens in the background that nobody knows about unless you tell them. And to be honest, unless you ask me about it, or I'm geeking out about it, I'm probably not going to talk about this part. But then again, I'll probably talk about it anyway. All right, let me plug some stuff in, and then we'll get up to the races here. All right, so first things first, I am going to plug in the board for I forgot a cable. Where's my other cable? There's my other cable. This is a short cable. Is this... Wait. Am I short a cable? I better not be short a cable. Oh, wait, I know what I did. This might work. You know what? Let me try it. Decisions. Well, it's hardware-based, right? Yeah, let's try this. Let's see if it works. I'm going to just plug in the USB port, and we'll see if it appears where it's supposed to. All right, cool. Fantastic. So the controller's plugged in, and you can see right there. I cannot see the name of who just popped into chat. Hello. I will read your message in a moment. I'm a little far away. My eyes don't see that well. And now it's waiting for the screen to get plugged in. And it will sit there indefinitely until I plug the screen in. So let me do that. Boop. Plugged in the screen. And bang. Off we go. Now. Yeah, let me see who popped in here. Oh, howdy, Rick. Welcome on in. Let's see here now. Why don't I have sensor data? I should have sensor data. Well, that's fun. Lovely. So I did run across this problem before. And I'm suspicious that it may be with how large of an integer or how large the main int is. Because I can tell you right now that I ran into an issue with this before where actually, you know what? Wait, I didn't use this chord last time. That might be a power only chord, which means no, we should still see stuff because I have it plugged into no, we're seeing stuff in the terminal. That doesn't make any sense. Well, the last time I had to fix this, I restarted the terminal, so let's do that. So we're gonna close that. Gonna go back to the Protogen Head. We'll go back to the controller. I'm gonna open it back up again. Now this is still gonna present nothing. Interesting. All right, I'll bite. Last time I did this, I restarted and it was happening. So let's try that. You know, it's funny. Most people would be horrified of having that happen. No, it's okay. We can reboot. I have magic. We'll still be here. Because I'm using some behind the scenes voodoo. All right, we're gonna give that a minute to restart. And then we'll see if it behaves or not. Hopefully it will. I know for a fact that is functioning code because I had literally powered them off with proof that it was working. Now I do know it ran across that before where the I2C protocol crashed and it stopped receiving information from the controller. And I thought it was just a you had to reboot and you were okay again kind of problem. But I'm not so sure now. Well, we're gonna wait for this to just restart. And I'm gonna disconnect both of these. We'll get ourselves going again here. And we'll see where that leaves us. All right, computer's back up. Let me get the projects loaded back up here. Just a moment. So we're gonna get the screen project open and we want the controller project open. The other thing too I'm going to do is I'm going to switch back to the cord I was using. I'm wondering if maybe that stubby is not compatible that I just grabbed. That might be bad. Okay, so we're going to go back over to here. So this is where we left off after a reboot. I'm going to switch out the cord and then I'll plug them in and we'll hopefully see something better occur. Here's the hoping. So get that, put that back in a box. Actually, do I have that other cord over here? I do have the other cord over here. Good. I'm gonna use it. At one point, I guess I just never unboxed this, which realistically speaking isn't necessary. Alright, so I'm going to plug in our microcontroller for the controller, the Wii controller. Alright, so setup is complete on that one, and then I'm gonna plug in the other one, and with some data lines, hopefully. Okay. I'm seeing nothing. Why am I seeing nothing? Yep, that is what plagued me last time. I2C error, burst read, error 4, repeated 1, which means it's not talking to the microcontroller, which means I'm going to receive this cable in hopes that maybe it's loose. Because there's a really tiny cable that connects the controller to the rest of the project. And if it's loose, that will go poorly. So let me see you in there, and then you back into here. And of course I have to restart because it forgot who the other partner in crime was. And I'm still dead to the world. Well, that's disappointing. I guess I will lower that priority value and see if that makes a difference. You know what? I wonder if I just re-upload the sketch if that'll fix it. Well, only one way to find out, right? And that's to do the thing. How do you set? Welcome on in. I'm in the middle of doing bad things to my microcontrollers, apparently. Here's to hoping that this will fix it. Because we should see on the controller side information that is from the controller. Now I can tell you that ESP-NOW is working because you remember how I said I hard set that value for the device type to be 32, which spells out nunchuck? We're seeing 32 appear on the other end. So we do know that it is making the connection to the other end. It's just getting garbage data. Remember how I said garbage in, garbage out? Haha, it's relevant. This is why. Please work. No. No, are we really gonna leave the friends at home without the cool thing? I'd like to show them the cool thing. I think we should show them the cool thing, don't you? I think we should. I don't know how good of an idea it is to reseat this cable while it's running, but I'm gonna do it anyway. Time to do some sketchy shit, doo-da, doo-da. Hope we get away with it. Here's to hoping. Nope, I'm broken. Well, I'm going to stay broken for right now until I can figure out what that's all about. That's a little disappointing. If it really is a memory overflow, which I don't think it is, lowering this value to something smaller should likely fix it. So what we're going to do, which is a great thing to do when you're troubleshooting, is make a copy of the original code and comment it out. That way, if I do end up managing to screw this up further, then I have a way to go back. So that is where we're going to be. So I'm going to lower this to a smaller number. Now hopefully I'm going to lower it not too much to the point that I lose my priority as the master, or the code won't work. So let's chop off 2 digits and upload it. And then I'll reboot both boards and see if we play nice. Because right now, we are not. Got a bunch of garbage data here. Well, technically speaking, I am still getting... It really shouldn't be that, right? Because I'm still seeing that valid value of 32 indicating who... Oh, it's 44% of the program storage, right? I'm still getting this value on the other end, which is technically the only valid one right now. And I'm not actively pressing a button, but these will still read as true because there's junk. So there is a chance in the water I may have damaged something. You just don't know it yet. But we're going to find out. Nope, I squared C error. All right, well, I'm broke. That's sad. Shoot. I wonder if I shorted something out. Could I have shorted something out? I might have. If I did, it clearly wasn't intentional. Well, it's plugged in there. Where am I on the other end of this? I am on the... yeah, the inside of this little dude. Yeah. Whatever is occurring, I'm not entirely sure what. I'm trying to remember, there was something else I did that made this start working. I put this in boot mode. Maybe that's what cleared it last time. So there's a boot button on these, so if you accidentally brick the board, you can unbrick it by holding the boot button. And all I'm doing is just putting it into boot mode and taking it back out. And we'll see if that hopefully makes us a little happier. First error. All right, well, that's enough of that. So I had it working and now it's broken. I haven't changed any of the code, which makes me think that something to the hardware has occurred, which means that it's all open electronics. So something could have shorted out, or I have an oversight in the code that was working and then suddenly stopped working. That's not normally how code works, which makes me think that I might have broken something. But I have some spare wires and some spare boards that I could plug in and out on, and that will happen, just not here, at least not immediately until I figure that out. So as far as the coding portion goes this evening, I have spent an hour and a half to show you something that won't work, but it did work. And I have no proof of it because I wasn't live. That's sad, but yeah, that's how it goes. I do know that this is working though, because this value is coming across the device type. I'm hard coded in, it's here. It's just the protocol that it accepts this information is no longer functioning. One more thing I want to try. Actually, let me close that. And we're gonna go into here. We're gonna go into older. I have a botched folder and she'll love that. I'm gonna overwrite that sketch with a different one. Because this one just accepts and then dumps to the terminal. So I'm gonna go to the serial monitor. I don't want to accidentally erase the wrong one. I'm going to disconnect the screen. That means there will only be one option in here. I did have it right. It was COM4. I wanted to be sure. That's interesting. This is connected and it doesn't see it right now. Huh. Remember how I mentioned there's that boot button? I'm going to use it. So the way this works is I'm going to hold the boot button. I'm going to plug this in. It's going to attach to the computer with a different port number. And then I'm going to change it. And we're going to do stuff. So I'm going to go to here. It shows up as 5. And I'm going to upload this code over top of the project. I have copies of all this stuff, so it's fine. Oh, that's what the problem was. I didn't have that selected. That's not technically the right board. It's that one. And we'll push that up. This will essentially just push up a very watered down sketch that just activates the accessory and just dumps to the screen. Exactly what we're trying to send across the wire. Because if I get sensor data like this, then we know that the hardware is functioning and something bad has occurred with the code. Okay, and then to reset the board, because I did have to put it in boot mode, I'm going to disconnect it, reconnect it, and switch the port comm back. Because we're back on 4. And look at that! Sensor data behind my ears. So it's nothing goofy's going on, because that's the stuff that we should have seen. Now, of course, it won't appear over here, even if I did plug it in, because this sketch doesn't have the stuff to send it over the wire. So I'm going to close this. We're going to re-upload the other sketch and see if that clears out whatever may be broken. So I'm going to go into the Protogen Head. What concerns me is the potential of a memory leak. Because if there's something in here that I'm not accounting for, because again, I didn't get all the code out that I'm not currently using, it could be causing mayhem in the background, causing the I2 protocol to crash. And that's not good. And as far as it goes right now, I don't even need to plug in the screen because it's only going to receive nothing other than the hard-coded 32. Because we saw that. There's nothing wrong on the receiving end, it's on the sending end. Actually, I have to plug it in because the code dictates it or it won't start. That's right. It's alright, we'll push it and see where that puts us. Okay, so this now went through all the bits and bobs and it's booted. And now I'm going to plug the other one back in. And we'll see if the controller board crashes again. Now isn't that peculiar? It's working. So I'm a little bothered that by erasing the board and re-uploading a different sketch, it fixes the problem. I thought I had done something similar to this before, but this is, like I said, I didn't change. You just witnessed, other than, well, I guess I did adjust that variable to be smaller, but again, we saw traffic going back and forth. Assuming that I didn't accidentally choose a number that was too big, causing things to go out of memory and break. Well, I guess we'll know if this works if I restart them again, right? Because we have the controller on this side, and behind my head is the sensor data. And we can see that whizzing by, and then over here, this is the board, the screen accepting it. So if I grab the controller right now, and I click the C button and the Z button, they appear. If I let go, they'll disappear. If we take a look at that joy value, we will see that it's going to change as I rotate the controller around in my hand. So, what has occurred? Something that's unintentional, clearly. Good news, I didn't actually damage the hardware. Bad news, other than changing that one variable to be smaller, and I don't necessarily know if that was it, this may or may not be resolved. I'm gonna restart both boards and we're gonna see what happens. So remove power. Interesting. So when I remove power from the board that's sending the data, the first board then just keeps holding on, just keeps showing what was in memory. All right, so that one's restarted. And that one's restarted. And it died. All right, well, good news, bad news. Good news is the first time I program it, it works. Bad news is it doesn't on next boot, which means I have something in this code that's causing trouble, which means I still have more work ahead of me on making this behave. I have to find out what would cause that to crash. To clarify, the ESP-NOW is working because it's still sending the data over to the other side. I can see that because the one value that's hard set is here on the other side. And we're sending zeros and 2 trues for the C and the Z, which is why that's appearing. So back and forth is working, but the step that causes it to read the sensor is what's crashing. So, and unfortunately, I'm broke. Still, unfortunately. But that at least makes me feel a little bit better, is to at least know that it's repeatable, which means that at least I have a mechanism to troubleshoot with. So, with that,